my dear student. Hello, my dear student. Hope so all of you are fine. Today we are going to learn about sound waves part 4. All right. And lesson objective for today, we are going to learn 4 different types of past paper questions regarding sound waves and the techniques how to write the answers on the answer script in a given space. Right, so let's go to begin our class for today. You can see that question number 4. Before that, question number 1, 2, 3, I explained to part number 3, sound waves part number 3. Here you can see that figure shows the variation of air pressure with distance from a speaker at one instant. On figure, mark on the axis XY. So let me explain it to you. Do not think, I said to you before also, that do not think that if this type of wave means that is transverse wave, because this one that is representing air pressure versus distance. So air pressure versus distance means this is a longitudinal wave graph. It does not mean that the particles are moving up and down. Actually, the particles are moving left to right, but sometimes the particles are distance apart, means their air pressure is very low, less, and sometimes the particles, they are very closer together, so their air pressure is a bit large. So this graph in terms of air pressure, not in terms of distance versus time. All right, so this graph is going up and down. It does not mean that the molecules are going up and down. Actually, the molecules for sound wave, they are moving left to right, but sometimes molecules are close together, sometimes they are farther apart. Okay, so do not think that sound waves particles or sound particles are going up and down. No, sound particles are still vibrating left to right. Okay, so move on to the question. Over here on figure, mark on the axis XY, and as well as one point C where there is a compression, and one point R where there is a rarefaction in the wave. So we need to mark 2 points, and we need to write that point C and point R over there, right? So this is our condition. Now see over here some explanation. You can see normal air pressure, that is X2Y. All right, so distance from the speaker and the air pressure. Yes, now is your concept will be very clear here. That means, see, at X, that means the molecules are farther apart. That means these molecules are vibrating left to right, but over here they are further apart, means their air pressure very less. So I can say the air pressure 0. And over here, low air pressure region. So over here the air pressure is less, no pressure at all. But over here the pressure is high. So whenever the pressure is high, on that time it will show this point, crest. It does not mean that the sound waves are traveling up and down. Actually, sound waves are traveling left to right. But over here we are showing the air pressure by the sound waves, not the direction of air particles, pressure of air particles. All right. Okay, so now how can we understand or identify? Now see that point C, how you need to write. You need to write point C on the equilibrium position. That means one point C where there is a compression. Do you understand? So that means this is our compression. This point represents, this is our compression, and this point represents, this is our rarefaction. So the compression, then after that the air pressure 0, then after that there is rarefaction. Again air pressure 0, again there is compression, again air pressure 0, again there is rarefaction. So like this it will move on. All right, if you understand, very good. If you do not understand, pause this video and go back and again watch it. All right, so the next question, sound waves shown the sound wave shown has a speed of 330 meter per second and a frequency of 132 hertz. Calculate the distance represented by x, y, xz on figure. So it's very easy question. That means we know the speed of sound and the frequency, but the calculate the distance represented by xz. Now see that xz represents half wave, not a complete wave, right? See that between these two red lines, that is wavelength, means that is a complete wave. But they say technically that you need to find out only xz, mean that is lambda divided by 2, lambda, L-A-M-D-A, lambda. So v equal to f lambda, so lambda equal to v by f. So v, that is 330 meter per second, and f, that is 132. So we can find that 2.5 centimeters, that is wavelength. My dear, this is not our answer, because they asked lambda by 2, half wavelength. That means the real answer will be 2.5 divided by 2. That means 1.25 centimeters. Alright, so hope so you understand. Now this is for question number 4 we have completed. Now this is question number 5, drawing sound waves. In this question we are going to learn how to draw sound waves on your exam paper. Now see that in the space below, draw a diagram to represent a sound wave. On your diagram, mark and label 3 compressions with letter C and 3 rarefactions with letter R. The wavelength of the wave with letter lambda, wavelength. So I'm gonna give you some space on your exam paper, and you need to use your ruler and you need to use your pencil to draw it very perfectly on scale. Alright, see over here that you need to give some lines. You need to draw many, at least 2 compressions and 2 rarefactions part, that is okay. But they said 3 rarefactions in this question, so that means you need to draw 3 rarefactions and you must mark C, C, C. C represents compressions, air pressure more, not air direction. Okay, do not think again, these are air pressure, not air molecules direction. And you can see the slinky spring. If the slinky spring is moving, then you can see the compression parts and the rarefaction parts. So over here they said 3 compressions with letter C and 3 rarefactions with letter R. You can see over here 3C and 3R together side by side. Now you need to mark wavelength, the wavelength of the wave with letter lambda. Now see that we have taken the middle point of compression and middle points of another compression, consecutive compression. Then the distance between these two, that is called wavelength. You can see over here that is the another wavelength, distance between 2 rarefactions. You can see that how the examiner will give you 3 marks. First mark, diagram showing compressions and rarefactions, or you must give some lines. Second mark, 3 C's and 3 R's in the approximate correct place. You must write this C, C, C and R, R, R. That is in the correct position, means 1 mark. And then third mark, wavelength correctly marked by I. That means by eyes.